All right, now we have 1.7, which is our distance, midpoint, and slope formulas. These three formulas you will need to memorize for the whole year. Don't worry, we'll make it easy for you. We'll do them a lot, we'll write them a lot, but let's go ahead and get started introducing these. So we've got the distance formula first. That measures the distance between any 2 points with coordinates x1, y1 and x2, y2. That means those little ones and the little twos mean the first coordinate and the second coordinate. Simple as that. So we've got our distance formula right here. We subtract our x's in parentheses and then square it. And we add it to our y's subtracted in parentheses and squared. And then at the end of all of that, we square root it. We're going to make it really easy, break it down step by step. So you know, it could ask, what is the distance? It could ask, what is the length of a line? It could use a bunch of different words, but if you need to find how far 2 points are from each other, you will always use the distance formula. Let's do an example so I can show you how this formula works. So I always go ahead and start by writing out my distance formula because it will help you memorize. So subtract your x's squared plus your y2 minus y1 squared. All right, now the problem says graph the points -6, -2, and 3, 4. So, and then we will find the distance. Let's go ahead and graph those points. So we go to -6 on the x-axis, and we will go down to -2. Notice that the graph is, all the tick marks are going by 1, but it's labeled going by 2. So always double check that you know how your graph is presented. So -6, -2 is right here. And then we've got point 3, 4 right here. And let's go ahead and connect those with a line. All right, so we're going to find the distance of that, or the length of that line, or the distance between those 2 points. So I can label these points as x1 and y1 because coordinates are x, comma, y. Now this coordinate here is our second one. So x2, comma, y2 for our second coordinate. Now that we wrote out our formula right here, let's just go ahead and plug in where it tells us to. So I will put that big square root all the way across. Then my x2 is right here. It is the 3. Make sure I put that parenthesis in there. Then I take my x1, which is -6. Close my parenthesis, square it. Plus, now I take my y2, which is right here, 4, minus my y1 is -2. It's always, if you notice, it is the second coordinate minus the first. You subtract your x's, you subtract your y's. And it is squared. All right, so let's go through this step by step. We're going to break this down. We're going to get to the square root at the very end. Let's start. Order of operations tells us to start in the parentheses. So 3 minus a -6. Minusing a -6 is the same as adding +6. So 3 minus -6 or 3 plus 6 is 9. Keep it in parentheses. We haven't gotten rid of those yet. Then we will do 4 minus -2. Again, that's the same as 4 plus 2, which is 6. Squared. All right, take it another step. Now I can deal with my exponents. All right, 9 squared is 81. Notice, now that I've done the exponents, I don't have those parentheses anymore. And then 6 squared is 36. Now I will add what is under my square root. 81 plus 36 is 117. Now, do you know what 117, or the square root of 117 is off the top of your head? Probably not. So the best thing to do would be grab your calculator and type in the square root of 117. And it says to round to the nearest tenth place in our instructions, so we will call that 10.8. And we will call that units. Since there is no unit on there, these are 2 points on a coordinate plane. All right. Now we have midpoint, the second formula that you will need to know. The coordinate of the midpoint, so this is all still coordinates, between 2 points is the average of the x-coordinates and the average of the y-coordinates. So we add them together and divide by 2. So as you see right here, we added our x's together, divided by 2. We added our y's together, divided by 2. And notice that this is still in a coordinate because the midpoint is going to be a coordinate point. So the answer we get should be a coordinate. Whereas the distance is a length, so that is just a number. All right, so let's do an example. We've got, find the midpoint between the points, -6, -2, and 3, 4. So the same coordinates we used above that we graphed. Let's go ahead. This again will be x1 and y1 and x2 and y2. Same as above. Now, so it says that I'm going to add my x's together. I like to always start off by drawing a big coordinate. Now, with the comma, I've got 2 sections. Let's add my x's. I've got a -6, and I will be adding +3. Those are in my x spots of these coordinates. And it says to divide it by 2. Now, I'll take my y's, -2 and 4, and add those together. Notice this one is x1 plus x2 and y1 plus y2, because when you're adding, addition is commutative, so it does not matter the order. All right? So now let's just do the math. All right? So -6 plus 3 is a -3, and we would still need to divide that by 2. Then -2 plus 4 for our y's is 2, and that's still going to be divided by 2. So I think we need to do a little bit more simplifying for this coordinate. -3 divided by 2 is a -1.5. We're going to actually leave that as a fraction, and that is in its simplest form. So we will still keep that as -3/2. But 2 divided by 2, we can simplify that because that is just 1. All right? So that is the midpoint between these 2 points. It is the middle of this line. And let's go ahead and check. Let's plot this point up on the graph where we plotted this line. So I'm going to plot at about -1.5, so I'll go about halfway between 1 and 2. And I will go up to 1. All right? Since my line wasn't so straight in the beginning, it's hard to tell, but does this look like it is in the middle of this line? It should, and it is, because that is the midpoint of that line. All right? Now, the next example is the harder version of a midpoint question, but we're going to make it really easy for you, all right? So given the midpoint of some line AB is 2, 1, and point A is at -3, 5. What are the coordinates of point B? So now I actually have the answer to a midpoint problem, and I have one of the endpoints, and I need to find the other. Let's start by graphing this so we can kind of get an image of what we are working with. So the middle of line AB is at 2, 1. So that's going to be my midpoint. I'll label it with an M. Now point A is at -3, 5. Let me switch colors so we know this is an endpoint. -3, positive 5, so I need to actually be going up. There we go. There is point A. All right, so if M is in the middle, if I were to draw a line here, that's the middle of it. I need to go past the middle of it. So point B is going to be somewhere probably in this area. We aren't going to guess, we're actually going to solve for it, and then we'll check that it makes sense. So let's plug into our formula again and see what we know. So our formula, I'll rewrite that out, is x1 plus x2 over 2 and y1 plus y2 over 2. All right, now and that's going to give us the midpoint. So these x1s and x2s, y1s and y2s are our endpoints. So this is an endpoint. I can plug that in. I've got an x and let's fill in the formula here. And I've got a y is 5. Do I know what the other x and the other y are yet? No, that's what I'm going to solve for. So let's just keep them as x and y. But my answer, the midpoint, is 2, 1. All right, now we just match things up. We will set this part that would give us the x equal to the x. We set this part, which would give us the y, equal to the y, so that we have two small algebra problems. All right, let's do the x's first. Negative 3 plus x over 2 equals 2. To start solving, you need to get rid of this 2 on the bottom, so I will multiply both sides by 2. Negative 3 plus x equals 4. I will add 3. And x is going to be 7. So that is the x value of our point B. Now, let's do the y. So 5 plus y over 2 equals 1. Again, let's multiply by 2. What we do to one side, we do to the other. 5 plus y equals 2. I subtract 5 on both sides. Y equals negative 3. That means the y value of our point B is negative 3. So point B is at the coordinate. Our x is 7. So I put that in the x spot of my coordinate. My y is negative 3. I put that there. So point B should be at 7, negative 3. Let's go do 7, negative 3. And that's right exactly where we predicted it would be. That is the other endpoint past that midpoint we were actually given in the problem. All right, and last but not least, let's go on to slope. Here we go. So slope is the last formula you need to know. It's described as rise over run, or the change in y over the change in x. So we can talk about m is the variable letter we use for slope. If you see m, it's always asking for the slope. So we can say rise over run, or the formula is y2 minus y1 over x2 minus x1. All right, so let's do this first example. It gives us these 2 points. Find the slope of the line between 2, negative 3, and 4, 5. So my y's are on top. Notice again it's second coordinate minus first coordinate, just like it was in the distance formula. Let's label these points x1 and y1 and x2 and y2. Labeling those just as you get started will really help you out to make sure that you know which coordinate is which and you aren't making silly mistakes. Because if you mix these up, you will get the answer wrong, unfortunately. All right, so y2 is 5 and y1 is negative 3, so 5 minus negative 3. Those are my y's on top. And let's go ahead and put our x's on bottom. x2 is 4, and I will subtract x1, which is 2. All right, Now we just do the simple addition or subtraction, because 5 minus a negative 3 is the same as 5 plus 3, which is 8. And 4 minus 2 is 2. And now you simplify just the same way. 8 divided by 2 is 4. So the slope of this line is 4. It is a number. It is describing how it is the y's and the x's are changing. All right? The second way you can see a slope problem is on a graph. So let's find the slope of each line. Let's start with line M, which is this one right here. All right? So we need points to be able to plug into a slope formula. So it doesn't have them labeled. Let's go ahead and find some points that we can use. The points you can use are ones where it passes through exactly at like an X marks the spot on the graph, all right? So we can use this point, which is at 0, 1. We can also use, if we go down the line, not at a good point, not at a good point, here's a good point we can use. All right, that's 1, 2, 3 for the X and 0 for the Y. It did not go up or down at all. All right, now that we've got 2 points, your point on the left, because we always read left to right, your point on the left is your X1 and Y1. And here is your X2, Y2. Let's go ahead and plug it into the formula. Y2 minus Y1 over X2 minus X1. So 0 minus 1 is negative 1. 3 minus 0 is 3. Negative 1/3 is a simplified fraction, so we are done. Our slope is negative 1/3. Now, with line N. Line N is right here. I want you to try this one on your own. Pick out 2 good points, put them in your slope formula, and figure out what you get. All right, so go ahead and pause the video and solve for the slope of line N. All right, now that you have tried out that problem, let's go ahead and check your work. I've already put the work right up here. For line N, I was able to use 0.01 again, because that was a good point for line N. And then going up, I was also able to use 1, 4. There are no other good points that we know exactly the values of that coordinate, so you should have used these points as well. Now I put the work right here in this box. All right, so we had our 1, 4 coordinate was on the right, so that's our second coordinate. So we had 4 minus 1 is 3, 1 minus 0 is 1, 3 divided by 1 is 3 for that slope. So just make sure you got that correct. All right, now we have 4 different kinds of slopes that we should talk about. The first 2 are positive and negative slopes. So a positive slope means that it is going up as you read a graph from left to right. We always read left to right. Think of a book, all right? So this is going up as we look. Now a negative slope is going down as we look from left to right, all right? So we should have, this means we should get a negative number if it is going downward. And for positive slope, we should get a positive answer if this graph is going up. So if we look at those examples from up here, line M, the first one that we did, was going down as we read from left to right, and our answer was negative. And so that's exactly right. It's a good check that we did the slope accurately. And now line N was going up as we read from left to right, and we got a positive slope. So it is a good way to check your answers to know whether or not you should have a positive or a negative answer when you are done. The other 2 kinds of slopes we have are a 0 slope or an undefined slope. Let's start with a 0 slope. The way I like to try to remember this is that a 0 slope is a line that is a horizontal line. Horizontal has a Z in it, and so does 0. So horizontal has a 0 slope. You can use that to try to help you remember. But let's try an example so I can show you that even if you go ahead and solve this out, you will still get 0 when you use your slope formula. So let's say on here we go at about, say like right here is at about -2, 3. And right here is at about 1, 3. Let's go ahead and plug it into our slope formula. y2 minus y1 over x2 minus x1. Notice I was reading left to right, so here's my second coordinate. Here's my first coordinate. All right, so 3 minus 3 is 0. 1 minus -3, it's the same as 1 plus 3, which is 4. 0 divided by 4, or really 0 divided by any number, is still going to get you 0. And notice we should have a 0 slope because horizontal lines have a 0 slope. Next, we've got undefined slopes. The trick I use for remembering this is that an up and down line starts with a U, undefined starts with a U. So an up and down line or a vertical line has an undefined slope. You could also think vertical starts with a V. U and V are right next to each other in the alphabet. Really, you can come up with whatever you want to remember this. But even if you have to check using your slope formula, it's still going to work, and I'm going to show you exactly how. All right, so let's again choose 2 points. This seems... All right, so right here looks like it is at about 3, 2. And let's say right here we're at about 3, -1. We plug that into our slope formula, y2 minus y1 over x2 minus x1. -1 minus 2 is a -3. 3 minus 3 is 0. If you type this into your calculator, you will get an error. Let's go ahead and try that. Oops. -3 divided by 0 is an error. That is fine to get on your calculator because that should tell you right there that you have an undefined slope. You cannot divide by 0. I like to think of it as you cannot sit on an egg. You can't sit on an egg or you're going to break the egg. All right. So if you get an error on your calculator, you are dividing by 0 at any point. You have that undefined slope. All right, and that concludes 1.7 notes. For extra credit, you can go ahead and choose 2 points, find the distance, midpoint, and slope of those points, and we will check it when we check your notes. All right, see you in class.